there's a monolith there, a very unusual structure on this little potato-shaped object.
We can measure the data from these videotapes.
Ever heard of a hole in space so vast and empty it makes your backyard pit look like a puddle? Scientists recently stumbled upon something mind-boggling, a mighty void in the universe where there's absolutely nothing. They call it the Boötes Void, and it's not your average cosmic pothole. This black, empty space sits in the cosmos, far away from our little blue planet. What exactly is this void? Where is it lurking? And should we be worried? Stick around as we uncover how scientists found a terrifying hole in the universe where nothing exists. Boötes Void and the secrets of the cosmos. If you're up for a scare, then venture into deep space, far from our friendly cosmic neighborhood. It's so harsh out there that you wouldn't survive a second. But this isn't what's particularly terrifying about deep space. Here's what is. In deep space, there are a large number of mysterious holes that are outrightly spine-chilling and gobble up everything. Imagine being tossed into one of these massive holes where absolutely nothing exists. Terrifying, right? Well, that's the tale of the Boötes Void, one of the most mysterious void holes in the universe. Boötes Void, also known as the Great Void, is like a vast area in space where spotting galaxies is quite rare. It's an incredible 700 million light-years away from Earth, hanging out near the Boötes constellation. The name Boötes Void comes from its cosmic neighbor, Boötes. When we think about Boötes Void, we often picture Barnard 68, a mysterious cloud in space that stubbornly blocks out light. But here's the interesting part. Barnard 68 looks even darker because it's closer to us and has fewer stars in the way. It's like a cosmic curtain, making it harder for light to get through. Now let's think about how incredibly vast Boötes Void is. Light itself goes on an epic journey, traveling for a mind-boggling 330 million years to go from one end of this void to the other. That's a huge leap, especially when you compare it to the quick 8 minutes it takes for sunlight to reach us from the faraway sun. This enormous space only makes up a tiny 0.27% of the observable universe, which is a mind-blowing expanse covering a whopping 93 billion light-years. Boötes Void is like a cosmic giant with an estimated volume of 236,000 cubic megaparsecs. It holds the record as the biggest void ever found in the vast universe. But who was the first to discover Boötes Void? The journey of Boötes Void's discovery. Boötes Void came to light thanks to the hard work of astronomer Robert Kirchner and his team. As they gazed into space, they were stunned by what they found, an immense emptiness. At first, they spotted just 8 galaxies in this vast void. But as they looked deeper, they only found a total of 60 galaxies. The emptiness here is staggering. Just like having 60 galaxies spread across an area so huge, it's almost impossible to grasp. Astronomer Greg Aldering highlights just how massive Boötes Void is. He says that if we put our Milky Way in the middle of it, we wouldn't have spotted other galaxies until the 1960s, when we had advanced tools for exploring deep space. Our Milky Way has around 24 neighboring galaxies within a space of about 3 million light-years. Now, imagine Boötes Void, where experts thought there would be a whopping 10,000 galaxies in this huge area. That's quite a contrast to the usual distance between galaxies in the wider universe, which is millions of light-years. Boötes Void shows us how grand and lonely the universe can be. In this vast cosmic landscape, we're tiny, insignificant beings trying to understand the enormity around us. But how did Kirchner and his team stumble upon this unusual cosmic discovery? This super void that's not something you come across every day. Kirchner's team carefully studied galactic redshifts. These redshifts act like speedometers in space, showing how fast objects move away from Earth. Because the universe is expanding, galaxies farther away speed away faster. By understanding this relationship between redshift and distance, the team created a 3D map of the universe. On this map, they found something fascinating. A huge emptiness, about 700 million light-years from Earth. Imagine a roughly spherical space, around 330 million light-years wide. where you could fit our Milky Way billions of times. Surprisingly, this enormous area had very few galaxies, almost like a cosmic desert. At first, this vast emptiness was called the Great Nothing because of how eerily empty it seemed. Later, it got the name Boötes Void, connecting it to the Boötes constellation, linked to the mythic herdsman guiding the plow around the celestial North Pole. Since its discovery, scientists have plunged deeper into this cosmic mystery. They've conducted surveys that reveal more detailed maps of our vast universe. These maps look like a giant celestial web, showing how galaxies are arranged on an incredible scale. Most galaxies are part of long, thin structures called filaments, like threads running through the cosmic fabric. When these filaments come together, they form areas where galaxies gather intensely, known as clusters. In the grand cosmic display, huge empty spaces, stretching from 30 to 300 million light-years across, make up a whopping 80% of what we can see in the universe. Boötes stands out as one of the biggest, proudly holding the title of a super void, a massive expanse where galaxies are notably absent. But within these voids, some areas have slightly more stuff, creating a stronger pull of gravity. This gravitational force starts a sort of cosmic dance, pulling matter away from less crowded spots. As a result, these denser areas become even more packed, making their gravitational pull even stronger. It's like a loop where density leads to more density, shaping the incredible nature of the universe. At the same time, the universe is expanding on an enormous scale. What started as tiny changes at a quantum level now stretches across hundreds of millions of light years, forming the huge and complex cosmic structures we see today. Boötes Void creation theories. The discovery of Boötes Void has made scientists rethink what they know about the universe, shaking up established ideas. One big mystery is how matter is spread out so unevenly across the universe. This unevenness makes scientists reconsider how galaxies formed and spread out across the cosmos. So, how did a massive void like Boötes Void come to be? Scientists have been wrestling with this cosmic puzzle, using computer simulations to explore different ideas. The main thought is that smaller voids, something pretty common in space, start forming as galaxies pull each other with gravity. This pulling makes nearby areas empty out, and it's like a snowball effect. Once it starts, it keeps going and getting bigger. The idea that smaller voids merge to create a supervoid like Boötes Void presents a challenge to the typical explanation. The immense size of Boötes Void doesn't quite fit with the time since the universe began. It seems unlikely that only gravitational forces could have shaped such a huge void in that time frame. So, scientists explore other possibilities. One fascinating theory is that supervoids like Boötes Void might form when smaller voids come together, kind of like soap bubbles joining to make a larger bubble. Astronomer Greg Aldering, who noticed galaxies aligning in tubular shapes within voids, brings an important clue. This alignment hints at how these voids might have originated. Aldering suggests that Boötes Void could have emerged from smaller voids merging. Picture these smaller voids blending, similar to bubbles merging, creating a massive cosmic emptiness. The tube-like structures within voids might be leftovers from the borders between these smaller voids, where galaxies seem stranded within the vastness of the supervoid. Also, scientists widely believe that voids are remnants of the Big Bang. To find them, they focus on the cosmic microwave background, which is like a map showing the ancient radiation from the universe's beginning. In this map, voids appear as extremely cold areas, places where temperatures drop into the depths of space. These voids are like frozen expanses within the cosmic map, revealing glimpses of the universe's early stages. The origin of voids remains a puzzle wrapped in mystery. Scientists, driven by their curiosity, explore how these empty spaces formed, a complex dance that requires unraveling. One fascinating idea suggests that the massive Boötes Void grew from smaller voids merging in a grand cosmic dance. As the universe expanded, galaxies drawn by gravity gathered into huge structures. However, some scientists disagree, saying that the time since the Big Bang couldn't have created a void as vast as Boötes Void. The mystery revolves around dark energy, the elusive force behind this cosmic puzzle. We get hints about this mysterious force from quantum mechanics, a mind-bending field that gives us a peek into its nature. Dark energy makes up 68% of the universe, but we're still in the dark about its secrets. It's like a code we haven't cracked, shrouded in scientific mystery. What if the Boötes Void came about differently? This idea isn't found in scientific writings. Some suggest that the void might be linked to a super-advanced civilization. Imagine a society so advanced that it could cover stars and galaxies with something like a shell as it spreads out from its home. This could be why the void looks so round. The Boötes Void is far from Earth, about 700 million light-years, and if intelligent life started around 4 billion years ago, these super-smart beings could have had enough time to make this happen. It's just a thought, not a proven fact, but it's interesting to consider because the void is so mysterious. Let us explore how galaxies contribute to the complexity of this puzzle. Exploring the mysteries of space's emptiness. The reasons behind how empty spaces in space form are a big puzzle, and solving it is quite a challenge. The universe is massive, filled with countless galaxies, each with its unique traits. Figuring out how these galaxies interact and shape the bigger cosmic picture is a super hard job. Another tough part is dealing with things we can't see, like dark matter and dark energy. They're like hidden forces believed to have a major role in shaping cosmic patterns and gaps. But we're still learning about them, and without a clear picture of what they are, understanding how they impact empty spaces is tough. But even with these tough obstacles, scientists are actively studying this field. They're using super advanced tools like fancy telescopes and smart computer programs to dig into the mysteries of these big empty spaces. Surveys like the Sloan Digital Sky Survey give us a peek into how galaxies are spread throughout the universe. And computer simulations help us recreate how the universe might have changed under different situations, which helps test our ideas about how these empty spaces came to be. In the journey to unlock the secrets of these massive empty spaces in space, every discovery and every bit of data brings us closer to unraveling the truth. These huge voids hold deep meaning for cosmology and how we see the universe's structure. They offer a special view of dark matter and dark energy, those tricky and powerful parts of our universe we can't see. Dark matter, though invisible, shapes how galaxies and these empty spaces form on a grand scale. The very existence of these vast voids suggests dark matter had a big hand in shaping the universe we see today. Then there's dark energy, the mysterious force behind the universe's speedy expansion. It might also have a role in growing these voids by pushing galaxies away from less crowded areas, inflating these empty spaces over cosmic timescales. But these voids aren't just empty spaces. They're like cosmic clues that can help us fine-tune our ideas about how the universe works. They're a unique way to test our theories. If a theory can accurately predict the size and layout of these voids, it's a win. But if there are differences between what the theory says and what we see, it tells us we might need to rethink or even create a whole new theory of how things work in the cosmos. These huge cosmic voids, once seen as just empty spots, have become key players in our mission to understand the universe. If you were to fall into the Boötes Void, how would it feel? How would it be in the Boötes Void? People visiting the Boötes Void would likely feel overwhelmed by its sheer isolation. The distance between galaxies creates an incredibly dark and empty view of space. It's probably the emptiest place in space, like a perfect vacuum. Rocks, dust, and even particles would be super rare here. It might take forever or maybe never for particles to even interact. So if you're in there, you better be good at finding ways to entertain yourself. But there's more to this gigantic empty spot. The Boötes Void has such a low density that when neutrinos or photons travel through it, they don't change. They look the same when they enter as they do when they exit. Unlike these particles, matter particles with more mass would get pulled toward the void's walls because of this strange property. Because of this, someday, the Boötes Void might be seen as the ultimate time capsule, preserving things just as they were for a long time. Shooting out a set of photons and having that same pattern rediscovered hundreds of millions of years later when it reaches the other side of the Boötes Void. Because of its super low density, this place is perfect for testing insane speeds, like reaching up to 99.99999% of the speed of light. There's no pesky intergalactic dust to slow you down, making it an ideal spot to set some crazy speed records. Astronomers learn a lot from studying massive structures like the Boötes Void. It's like peering back in time to see what the universe was like in its earliest days. Today's scientists have top-notch telescopes and imaging tools that help them create detailed maps. For instance, the Dark Energy Survey has mapped out a quarter of the southern sky and checked out around 300 million galaxies in the process. How does the discovery of the Boötes Void make you feel?